This is Unit 11 Quiz Review. Okay, so we have an equation here. N equals 150 plus S. And I'm going to make a table. This would be N, this side would be S. And we have to name the independent and the dependent variable. The independent variable is always what's in the problem. And the dependent is always the answer. So take a look at our equation. Which one is in the problem? It would be S. And which one is the answer? N. And you are just going to substitute in numbers for S and get our answer for N. So let's go 10, 20, and then 30. So 150 plus 10, 160. 150 plus 20, 170. 150 plus 30, 180. There we go. Next one we'll have 5A equals B. Which one is our independent? Remember, our independent is in the answer. Which one is in the problem? I'm sorry, independent is in the problem, not the answer. Our independent is in the problem, and that would be A. And our dependent is the answer, always the answer, so it's B. Let's make a table. And we're just going to substitute numbers in for A. So 5 times A. Let's pick 0, 1, and 2. I'm just making these up as I go. 5 times 0 is 0. 5 times 1 is 5. 5 times 2 is 10. Okay, a gardener is designing a square garden, so here's the information for my square garden. He's trying to determine the different side lengths and how that will affect the planting area. So I need to create an equation. So you have to think to yourself, how do you get the area? Well, to get the area, you have to do either the side length times the side length, and that will give you area, or you have to do the side squared, and that gives you area. So either one of those equations will work. So we're going to take the equation, and 3 times 3, or 3 squared, the area would be 9 feet squared. 7, if I put it in here, 7 times 7, or 7 squared, which would be 49 feet squared. 9 times 9, or 9 squared, 81 feet squared. So I've completed the chart. I need to identify the independent and the dependent. The independent is always in the problem, so that would be the side, and the dependent is the area. Okay, we need to write equations to match our table, and I'm just going to go ahead and fill these in. This is a 30. Okay, so I need to write an equation to match these tables. And I forgot one here. And when we start out with an equation, we always start with x equals y. And we want to ask ourselves, what happens to the x number to get you y? What happens to 5 to get you 30? How do you go from 5 to 30? How do you go from 8 to 48? How do you go from 10 to 6? What's happening? It's timesing by 6. So you could write 6 times x, you could write 6x equals y. And there's our equation. Let's take a look at this one. What happens to 3 to get you 6? What happens to 12 to get you 24? We always start with x equals y, and it is timesing by 2. This one, what happens to 100 to get you 20? What happens to 125 to get you 25? Obviously on this one the numbers are getting smaller, so it's not going to be times unless it's going to be timesing by a fraction. So let's start out with x equals y. And try this one. How do you go from 50 to 10? Well, we divide by 5. So x divided by 5, and that gives me 100. And we can check it by doing 100 divided by 5 gives you 20. So check, it's a solution. Okay, here we have a graph. We need to make our table, we need to write an equation, and we need to identify the independent and the dependent. Let's take a look at the table first. So our line is going up, and we want to go from our hours and our amount of money that we make, and we want to where they meet. This should be kind of even. It's really not because I drew it freehand, but it should be even. So in 1 hour, he makes $5. And let's go up and try this one. Stop and come down. And in 3 hours, he makes 15. And let's try him. Let's try 7. Pretend it was perfect there. It should go up a little bit. There we go. And in 7 hours, he made $35. So the equation, what happens to 1 to get you 5, what happens to 3 to get you 15, what happens to 7 to get you 35. So always start with x equals y, and it's times 5. Remember, the independent is always going to be the x-axis, and it's always the part of the problem that's in the equation or in the problem. The dependent is always the y, and it's always the answer.